Well, in this talk, I will basically talking about how we provide high-level API of PubSub in the IoT scenario with our NDN-Lite library. And this is a joint effort within the UCLA group, and I'm the presenter, Tianyuan. Well, we know that PubSub is an asynchronous messaging concept. By using this high-level API, we can decouple applications into publishers and subscribers. Or we can say the PubSub is all about data, where NDN's data-centric design naturally fits. In TCP/IP, both end hosts not only need to be online at the same time, but also in one relation. That is, one publisher talks to one consumer over one connection. While in NDN, publisher can simply make the data available and doesn't care how many subscribers in the network. Data itself is secured, and all subscribers can fetch data with the same named interest, instead of having to stay in different connections or sessions. Also, the one note I want to make here is that the NDN-Lite PubSub is only a specific PubSub instance for our particular IoT use cases and not a generalized solution for broader cases. For people who don't know NDN-Lite yet, NDN-Lite is an IoT framework with built-in high-level system modules, security bootstrapping, service discovery, access control, and the PubSub, which is the main character of this talk, and the trust management, i.e. the trust schema part. And NDN-Lite is a library capable to run on resource-constrained devices, which only have no more than 50 kilobytes RAM and 100 kilobytes flash part. In this, on those resource-constrained devices, you need to make some particular design to make the library work. Then we made few decisions in NDN-Lite. First, we categorized home IoT functions into two types. They are either collecting data or actuating commands. Then we consider how can we wrap these two types of functions into PubSub. Collecting data, for example, monitoring the temperature in your home is apparently a subscription, subscribing the data that your temperature sensor just published. But also actuating commands, we argue, is also in the form of publishing command data and subscribing to those data. In this part, we share the same concept with Cassie's last year's ICN paper. That is, the commands, because of their carrying application payload, should go into data packet instead of interest. Now we came into the system component to see how many modules we have in NDN-Lite and what's the position of this PubSub. We have numerous system components within this NDN-Lite framework. For example, we have implemented access control, trust management, and PubSub as the application-facing interfaces for data communication. Besides interacting with the NDN forwarder, we'll also interact with these two modules to provide built-in security for application. So when application use PubSub to fetch data, the data is secured and authenticated. The overall namespace we are using is like this. Imagine you are running a smart home. So the root prefix of the name tree is the address home. And beneath this home prefix, you can have home service. So you can have automation application, which under the automation service, and you can have lock home service. Beneath this, you can have many door locks in different rooms. And say if a door lock at the front door want to publish state data, the name prefix it may use is like /home/lock /content/living room, then front door state. And separately, we have command type data. Say if application want to publish a lock command for a door lock, for a specific door lock at front door, the data will be named as /address home/lock /command, then living room front log, and then finally it will append a timestamp to achieve the data uniqueness. And as we just mentioned, in this namespace, both content and commands are data packets. Then think about if you want to turn on a specific air conditioners in bedroom, what name you should use? You may use ls home, then aircon command bedroom, then specific air conditioner, then append a command ID, say on. But here's a question that this name is pretty long, and how can we help applications to construct the data packet, to construct the name? So if we break down name into different parts, say if we break a state data published by a temperature sensor, for example, ls home, then temperature, content, bedroom, sensor, then state, we can simply break the data name into 4 different pieces. You have home service, data tab. Then you need a locator to indicate the effective scope of this specific data packet, then a content ID or command ID to carry the application to carry the fine-grained application semantics. Then, when you are trying to design a PubSub in NDN, there's always a fundamental question here. That is the timing between publish and subscribe. If you send interest too early, the data might not be created yet. And if you send interest too late, application may experience a long delay or latency. To this question, we have 2 answers in NDN-Lite PubSub. First, for applications that publish data periodically, say your temperature sensor, they publish temperature sensing every minute or every half hour. This content generated more or less periodically. For those applications, we send interest periodically. Given there's no perfect timing between different parties, if an interest arrives a little early, it can wait in the pending interest table for a short time. If a data generated a little ahead of the interest, it can be buffered for a short time. So by playing this interest lifetime game, we can provide an answer to this timing question between publish and subscribe in the scenario where data published periodically. But also, there are some applications that doing PubSub at unpredictable random times. So, for example, if you want to unlock the door, and the command is sent not periodically, you just click the button and issue a command. So for those applications, instead of having subscriber keep trying with sending interest, publisher would just give a hint, say notification interest to subscriber, and subscriber, upon receiving this notification, will send out the interest to fetch the command data back. This is the 2 answers we gave in NDN-Lite PubSub to the timing question. So with the above ideas in mind, we designed our API like this. First, if you say you are a temperature sensor and you want to publish a state content, you call this publish content API by specifying the home service as temperature and the 80 degree as the payload, then the state as as a content ID. So when you call this API, the PubSub module will first create the data packet and use the device level locator to publish content, because when a sensor publish content, in most cases, these data packets are effective locally, on sensor level locally. So after this data created, this data will be buffered in publisher's local PubSub module. And the PubSub module will register prefix for this data packet, for this data, and waiting for interest coming in and then give the data back. And for those applications doing PubSub as we said, at random times that don't publish periodically. When, say, you publish a command to turn light in the bedroom on. So after create the command the data packet, it will send out the notification interest to the subscriber of this command. So subscriber can know the data just being created. So send the notification, so send the interest out and fetch the data back. When you subscribe, say subscribe the temperature bedroom, temperature data in bedroom. We said for those applications that data or content are generated periodically, you call this API by specifying the home service as the data locator, say bedroom here, and place an interest interval here to specify the interval of your interest sending, and the parser module will express out this interest with the can be prefix flag set and repeat this interest every 1,000 milliseconds to bring back the data. Also, if you want to subscribe to command, after you call this API, the parser module will register the notification prefix to receive any notification interest of specific command and locator. Say a command data just published and the publisher send a notification interest, broadcast it to the local network. Then the subscriber receive this notification interest with this name. And the parser module will infer the full exact data name out and fetch that command data with the exact interest. But also beyond simply fetching the desired published content or command data packet, application also may want authorized data. That means data produced only by authorized parties. Thus, we also need the trust management here help us to do so, to control who can sign what packets. For example, a home automation application wants to control the air conditioners in the same room. You may want to specify a specific signing rule. Say the data packet must be command data packet under the home service air conditioner, and the signing key name must under this specific home automation home service and the ID here to differentiate the identity data from other types, the command type or data content type. Then you specify the trust anchor that this parser module will use, which means under which trust anchor I perform these rules. If we illustrate with a concrete example here, say you want to publish temperature data with the content payload 70 degrees in bedroom. So you want to set the air conditioner temperature to 70 degrees. Sorry, this is actually a command publishing. You call this API, and the parser module will create a data packet and look up the encryption key in local key storage. Encrypt this data packet, sign it with the publisher's identity key, then make it available to the network, broadcast the notification interest to the local network. Then the subscriber part. By calling the subscribe to command API, it will first listen to the notification interest, right? Then after fetching the command data back, it will extract the signer's identity key name from the key locator space in the data packet. Then check against the trust policy to see if the data name and the signing key name follow same patterns I just specified earlier. If this trust policy check passed, it will look at signer certificate in the local key storage. Of course, if there's no certificate here, it will send an interest out to fetch the certificate back, because we know that certificate is another piece of named data. And after verify the signature of this data packet with the fetched or local cached certificate. The PubSub module will look up the decryption key of this home service in local key storage and decrypt the content payload out, say 70 degrees here, and deliver the command ID set the temperature and the content decrypt the content payload 70 degrees to the application. So the application, the subscriber side, can know that, okay, there's someone just published a command, tell me to set the temperature to 70 degrees. So we just mentioned how PubSub module will use this crypto material to enforce, to provide built-in security. But the question is, when are those materials, these trust anchor certificates, get into individual devices? Actually, in NDN-Lite, each devices, the configuration process start from out of band sharing. Say a QR code, they are either printed out on the device surface or just attached to somewhere to a device's service. So when you use NDN-Lite, you share this QR code to we call the NDN-Lite IoT controller. Then you click this bootstrap button to get into this trust anchor identity certificate and the trust schema part, the signing rule into those devices. So the PubSub can know what rules I perform. So as you can see here, the security are really designed into these PubSub APIs. When applications use the PubSub interfaces, the data exchanged between devices are secured and authorized. Any data that does not satisfy trust policies will be dropped by this PubSub module. And data not signed by correct parties won't go into application space. So the application and developer can focus more on implementing the logic instead of dealing with low-level interest data details or dealing with specific crypto stuff. So in summary, our NDN-Lite PubSub, we organize the application with name tree. As you can see, the publish is just set or attach an application object to a specific name tree node. And subscribe is like attach an interested flag on a specific name tree node. We organize the application with the name tree so the developers can focus on high-level logic instead of low-level details with our high-level APIs for application. And we provide built-in security for developers. Well, we still have some limitations. For example, now we do not very good at providing reliability for applications, but that's the part of our future work. And you can play with our code on this website. There are documentations, many examples, or even some detailed design draft here.